All right, hello everybody. Okay, so we are doing 9.6 counting principles. It's a nice beginning to probability, a little bit of stats, but I kind of like it. Makes probably one of my favorite sections. Gets you to think about how you can figure things out in just everyday life. So a little bit of word problems. Again, a lot of it's just breaking it down. I like to draw things out, especially when I'm doing with problems like this. So I'll be moving back and forth with this to the other parts. Actually, I think I could just do this right here. So again, counting principle. Let's see if I can just move it down here. There we go. Okay. So here's what we're going to do. We've got this problem right here. Okay. We're going to have 8 pieces of paper, and we're going to number it from 1 to 8. Okay. So we got 8 pieces of paper. Okay. Wondering if I could copy that. I don't know what's going on here. Six. And we got 8 of them. Whatever. So we've got 8 pieces of paper here. Okay. And we're numbering them 1 through 8. And we're going to place them in this box. Okay, so all of them are going to get placed in the box. And what's happening here is we're going to take one at a time, and then we're going to record it. We're going to take the paper and put it back in the box. We'll draw a second one, record it, and then we'll have 2 numbers that we get. We want to figure out, when we pull out those 2 numbers, how many different ways can we obtain a 12 when we add up those 2 papers. So all these are going to go in this box. Okay. And then let's say we pull out a 3 from there on a piece of paper. We're just going to record it, and then we're going to put it back in. And then we're going to grab another piece, or just grab another piece of paper. It might be the same one. It might not be. And the second piece of paper is a 7. If we add those, that's going to be 10. Okay. What we're trying to find is how many different ways we can obtain 12. Okay. So obviously 3 and 7 is not going to make 12. So what we want to do is look for some combinations in here that would add to make 12. So right away we could see that the max number we have is 8. So the minimum number that we could use to combine to get 12 is going to be 4. Okay, so if we start out with 4, okay, we can't use any of these because there's just nothing in there that we could add to 1, 2, or 3 that's going to equal 12. So if we start with 4, okay, we'd have to use 8 in order to get 12. 5, we'd have to use 7 in order to do 12. 6, we'd have to do 6. Okay, so those are combinations. But the thing is that we are taking a piece of paper out and then putting it back in. So let's say this is the first piece of paper we get. It's a 4. That means the second has to be an 8. The first has to be a 5, second 7, then 6 and 6. So right now, all we have is 3 different ways that this can occur. But we could get a 7 on the first one, and then get a 5 on the next. We could get an 8 on the first one, and then a 4 on the second. So the amount of possible ways that we could come up where the sum is 12 is 5 different ways. Okay. So up here we have 5 different ways. Okay. Now, let's take a look at the second part. Actually, I don't think we need the illustration anymore. You're going to place 8 pieces of paper, same thing, numbered from 1 through 8, and we're going to put it in that same box. So this time you're going to draw one piece of paper at random from the box, record its number, but this time we're going to leave the piece of paper out. So then we're going to draw a second one at random from the box and record its number. So same thing, we want to figure out how many different ways we can obtain 12. So let's do the same thing here. Let's do the first piece of paper. And we'll do the second. Okay. So, say the first one we get a 4. We can't put the 4 back in. So, but we do have an 8 available. The next one we put a 5. And that means there still should be a 7. Now the last example, if we pull the 6 out in the first one, the problem is that if we don't replace that 6, we're not going to be able to pull out a second piece of paper with a 6. So we can no longer use 6 in here. So pull out a 7 in the first. Got to pull out a 5 in the next. 8 and 4. So here we have 4 different ways. Okay. And that's the just try and select pairs at random. So the difference between the counting problems in example 1 and example 2 is the replacement. That replacement changes everything in there, and that is why card counters in Las Vegas get themselves with an edge, as they understand how the probabilities work. Okay, and that's the main thing. All right, let's move on to the fundamental counting principles. I think I'll stop at telephone for this one. Okay, so fundamental counting principle, it states that let event 1, or they'll say E1 and E2 be 2 events. First event, E1, well, it can occur M1 different ways. And E2 can occur M2 different ways. So if you have one event occurring this many ways, second one occurring that many ways, how you can figure out how the number of ways that 2 events can occur, you just take the M1 and multiply it by that M2. Okay, so this is our fundamental counting principles. So right here, we're trying to figure out how many different pairs of letters for the English alphabet are possible. Okay, so English alphabet has 26 letters. Okay, so we have 26 letters. Okay, so that's A, B, C, all the way down to X, Y, Z. So again, we're trying to figure out how many pairs we can make possible. So when we pull out for one letter, we have 26 to choose from. Okay. On our next letter, again, we're talking about pairs. We're not talking about without replacing one. We could choose at random. We have another 26 to choose from. So therefore, 26 times 26 gives us 676. So there are 676 ways possible that we can create, or 676 pairs of letters that we can make from the English alphabet. Okay. Okay, so let's take a look here. The telephone in the numbers in the United States have 10 digits. The first 3 digits are the area code, and the next 7 are the local phone number. So you want to figure out how many different telephone numbers are possible within each area code. The first digit in the telephone cannot be 0 or 1. Okay, so let's take a look at that. You got a phone number. Okay, you got your area code here. This is our area code. Okay. And here's the number. 3. And it's 4. Okay. So the first digit in each telephone number cannot be 0 or 1. So first of all, let's figure out how many total possible numbers there are to choose from. We're going from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Remember, these are all single digit numbers that we have to put in there. So the total amount that we could use in each one is 10. Okay. So here we're talking about how many different telephone numbers are possible within each area code. So right now we're not going to worry about the area code. We're just going to worry about the local number. And again, it says the first digit of the telephone cannot be 0 or 1. So therefore, in this first spot right here, we can't use these, so we only have 8 digits we can choose from. Now the rest of them don't matter. So here we have 10 we could choose from. 10, 10, 10, 10, and 10. So basically, in order to figure this all out, we just have to multiply them all together to figure out all the possible different scenarios. Multiply it all together and we get 8 million. So there are 8 million different possibilities that can happen. Okay. All right. So this is the first part of it. See you tomorrow.